Hey everyone, welcome back to the PyKid channel. Today we're going to dive into an exciting project, building a console-based AI chatbot that can understand and respond to questions based on the contents of a PDF document. The project is perfect for beginners interested in AI, machine learning, and natural language processing. Let's get started. First, let's take a look at the project structure here. We have 6 main files: main.py, chatbot.py, embedder.py, pdfparser.py, vectordb.py, and verifier.py. Each of these files have a specific role in making our chatbot work efficiently, and let's go through each of them step by step. Starting with main.py, this is the main driver of our application, and this is the code right over here. It's not long, but it is very important. In main.py, we first import the necessary modules and functions. We have prompt session from prompt toolkit to handle user inputs, and various functions and classes from our other files that we'll go into soon. Let's break down the main function here, which is the entry point of our program. The first part is to check if a certain PDF exists in our directory. When we're coding, directory means folder, so here you can see document.pdf. That's in the same folder where all these coding files are, and we do this by first defining the path of the PDF, document.pdf, and if the path is invalid, we print an error message and then we exit the function. Next, we're going to call the parse PDF function to handle extract the text from the PDF file, because in a PDF file, the text is formatted very differently from like a plain text file. So this is really important in getting all that content out. Next, we're going to be generating the embeddings, and we generate embeddings for the extracted text, which we got using the getEmbeddings function. Now let's take a moment to explain what embeddings really are. In large language models, an embedding is a numerical representation of text. Think of it as converting words or sentences into vectors, which are lists of numbers that capture the meaning of the text. These vectors or embeddings allow us to perform mathematical operations on text, making it possible to analyze and compare different words and different sentences. Now, let's take a look at embedder.py, where we generate these actual embeddings. Embedder.py uses the sentence transformer model to generate these embeddings, and the getEmbeddings function here works as follows. First, we're going to import the sentence transformer library because that's what we're going to use for generating text embeddings. Then we're going to load the sentence transformer model over here. Then we're going to define the getEmbeddings function. If the input text is a list, we directly encode it using the model. Otherwise, we split the text into sentences, encode them, and then return these sentences and their embeddings. So what are vectors? In this context, vectors are arrays of numbers that represent the text in a high-dimensional space. Each dimension captures some aspect of the text's meaning. For example, words with similar meanings will have similar vectors. Let's go to vectordb.py. This basically manages our vector database using FACE. Now, FACE stands for Facebook AI Similarity Search. It's a library developed by Facebook that is used to perform efficient similarity search, especially on large datasets like this. The thing is, we can't give it the entire text because it's very, very long. That's why we're going to put it all into a database, and we're going to have the model search for the most relevant texts that are based on what the user's query was. First, we're going to define the vector database class. In the constructor, we initialize a face index with 384 dimensions and an empty list of paragraphs. The index flat L2 type of index we use here performs a flat search or a brute force search using the Euclidean distance. This means that it calculates the straight line distance between vectors. Next, we're going to add the embeddings to our database, and this function just adds it to the face index and the corresponding paragraphs to our list. Now we're going to search for the most relevant embeddings. It basically searches the index for the top k most similar embeddings. In this case, our k is 5. to the input embedding, and so it returns the distances in indices and corresponding paragraphs. Now, finally, we're going to reconstruct our embeddings, and this function basically just returns the embeddings for these given indices. Now let's talk about cosine similarity. Cosine similarity is pretty much a measure of the similarity between two non-zero vectors. It calculates the cosine of the angle between the vectors, which determines their orientation. In other terms, it tells us how similar two pieces of text are based on their embedding. A cosine similarity of 1 means that the texts are identical, while a cosine similarity of 0 means that they're completely different. Now, if you graph these two vectors as two lines with a length and a direction, and then you calculate the angle between them, you can imagine a triangle being formed. If you divide the length of the side next to it with the hypotenuse of that triangle, basically that is the cosine of the angle of those two vectors. And that's what we're going to be using here to determine whether the response generated by the model is similar to the actual PDF that we're using. And this is pretty much going to be used to mitigate hallucinations. Now what that means is when a model makes stuff up, it tells people false information because it thinks that's correct, but in reality there is no source for it. That's called hallucination, and a lot of large language models such as ChatGPT actually do hallucinations very often. So this is really important to kind of make sure that that does not happen. And this, we also do this in the verifier file over here. Now going back to the chatbot file though, because that's what we want to focus on right now. This handles the generating the responses based on the user's queries. So what we're going to do is we're going to import OpenAI, the library, because that's what we're going to use to generate the responses via the OpenAI API. Now the API is what we use to access GPT-4, which is the newest OpenAI model, and we're going to use that model to respond to the user. We're also going to be using .env to load the environment variables. Now the env file right over here, I'm not going to open it, but basically what it has, it stores my API key, and that API key should be kept private because if other people use it, that will charge your OpenAI account. But the API key is the code that you need to put in to actually access the API and to actually get GPT-4 to generate stuff for you. Now that's why we need this .env to access the env here. Now we're also going to be importing numpy for numerical operations and cosine similarity for measuring similarity, which we had just talked about. Next, we're going to be loading our actual OpenAI API key, and we're going to do it from the environment variables, and we're going to initialize the OpenAI client. So what that means is that now we're ready to start generating these responses. Before we do that, we should select the relevant context in these paragraphs that are actually important to the query that the user would ask. So this function finds the most relevant paragraphs and it sorts these paragraphs by similarity, and after that it selects the ones at the top, which are the most relevant ones, and then that it returns those. Now the main function here, which we're actually using to generate the AI model's response, it's called the generate response function. This function generates a response using the relevant context. We call the OpenAI API with the query and context, and we return the generated response. So basically we're telling it, you are a helpful assistant, use the following context to accurately answer the user's query by referring to these relevant texts, and after that we're going to give the model the prompt the user created. We are also going to be putting in the context of the actual PDF file, in other words the most relevant paragraphs that I just mentioned. And I think now we can get to the verifier file over here. The verifier.py file basically ensures the response's accuracy by comparing its embedding with those in the database. And so first we import the embedding model, then a numpy for numerical operations, and cosine similarity for measuring similarity. Then we're going to define the verify response function, and here the function just verifies the response by encoding it, then searching for similar embeddings in the vector database, and then calculating the similarity. And now if that similarity is above a certain threshold, then the Response is therefore verified. So that's pretty much it on the code. And I already have a set of questions that I have prepared to ask it. These 3 questions about the book. And now it tells us to ask the question because it tells us what we have to say. And so now let's paste our question. In which part of the book is the turning point of the whole story? After that, we wait for its response. Now, it actually gives us a response that not only analyzes and basically responds to our question, it also gives real quotes from the book to support its claim. Now let's ask it a second question. Once again, we wait for its response. Now it tells us Macbeth's wife is Lady Macbeth, and now it gives us a really analyzed response of that question that we asked. And as you can see, this is quite detailed. Now let's ask our third question. This time we're actually explicitly asking it for a quote, just to see if it actually hallucinates or if it provides a real accurate source of information. Great. So now it gave us a quote that best encapsulates Macbeth's desire for power, and this is actually a real quote. You can go and search it up, but pretty much this is what the AI model does. All this code, it culminates into this one model that we've basically kind of trained by giving it these relevant paragraphs or embeddings from the vector database, in which we're storing all the text that we parse from our PDF. So after all of that, I hope you were able to understand how I coded this, and I actually encourage you to go ahead and go to my GitHub, which I've linked into the description. Go to this repository, which has all the code, fork it, and kind of add your own features or play around with it and see what you can do, because this project is a great way to get hands-on experience with AI tools and libraries. So that was it for this video. Thanks for watching. If you found it helpful, please give it a thumbs up and subscribe to the PyKid channel for more AI and Python programming tutorials. If you have any questions or suggestions for future videos, leave a comment down below. That was it for this video, and I'll see you in the next one.